All right. Let's do a very quick recap of what we talked about last time. Okay. Basically, we talked about substitutions. Okay. Let me just give you a very quick principle you should really always remember. So far we talked about two kinds of types. We talk about static type, and also we talk about dynamic type. Okay. So these are the two possible kinds of questions I might ask you later. Okay. So now, if I might simply give you a fragment of code or line of code and ask you if the line should compile or not. Whenever I talk about compilation, so what does that mean? If there's any red underline, if you put the code into Eclipse, in order for you to judge this, you only look at static type. Okay? As far as compilation is concerned, only look at the static type. On the other hand, if the question is more like, if a fragment of code actually compiles, how would it behave at the runtime? It's a second kind of question, right? About runtime behavior. In which case, you have to more consider about dynamic type. Okay, we'll see examples for both. Okay, so that's just some guiding principle for you. Okay, whenever I ask you about compilation, only you focus on static type. Don't worry about dynamic type. When I ask you about what's going to be the runtime behavior if you try to execute the code, look at the dynamic type. All right? Okay, we'll see. Just keep these two principles in mind. A very quick recap, and then we'll move on to the new topic. Okay, and then I'll define polymorphism and dynamic binding. So we talk about substitutions. So substitutions are mainly just about assignments, like a variable assignment that we talk about. Okay, so now I'll give you one example. Every time when we talk about substitution, you are really given a particular inheritance hierarchy over here, where each arrow over here is simply just extends. In this case, B extends from A, and C extends from A as well. Okay, that's something easy to draw. I will have some exercise for you at the end of today. When we talk about substitution, we are really asking, for example, let's just assume we got so many classes. We got A, B, C, D, E, F, G, H, I, J. These are the classes we got. Let's say we also declare variables of the various static type. As you can see over here, all the types over here are the static type, right? That's how we declare the variables to be static types. Okay, and then let's say we have a variable OC of static type C, OC2 of the same type, OA of static type A, etc. Okay? Now, what we want to see is what would be the compilable or safe substitution to make. That's something we have to know. Okay? I will show you some idea and then we'll show you on the diagram as well. Okay? So now let's say the following. If we got something like here, OC. First of all, what's the static type of OC as far as you can see? C over here, right? Let me mark it. Over here, C over here, let's make it very precise. So C over here is a static type of OC. So now we got the following question. Whenever you have an assignment like OC to be the targets, and then the assignment symbol, what can we put on the right-hand side? Okay, that's the question basically. We have already talked about this last time. I'm trying to present in a different angle. From what you can see on the variables over here, which ones can be safely put on the right-hand side? That's the question. Okay? Yeah, can we put OC2? In this case, OC2 is okay. Okay? So how do we judge, first of all? How do we judge? What's the rule for this? So what you got to think about is, you're basically asking for OC, the static type is simply just C, which is over here. And when we say we want to do an assignment over here, we're asking what can we substitute for OC? When we talk about substitution, that means you want to substitute with anything that has got at least as many expectations as before. You cannot substitute with anything that has got less expectation. So now, if you look at diagram over here, which classes has got more or at least equal expectation as C? We talked about some terms last time, right? We talked about ancestor, we talked about descendant, right? So which classes actually got at least many expectations as C? Descendant or ancestor? Descendants. So let me write it down. So that means over here, I'm going to select by pink. So this is the area. So these are all the descendant classes. Descendant classes of the static type of C, right? That's the descendant classes, which means every class I have chosen over here, they got at least as many expectation as C. So that means we can safely substitute them for them. Okay? For example, I can say OC2. I can also say OF, for example, right? OF, you can see over here, OF is of static type F. So that is okay to substitute it by here, right? Can I say, for example, OE? Can I say OC is assigned to OE? Can I do that? Wow. How do you judge? Basically, you got to see what's the static type of OE. The static type of OE over here is simply over here. I didn't declare that. I should have put it. So let's say, let me do it here. If I say E over here is of static type OE, right? That's over here. So now, if you look at this particular substitution here, the static type of OE is E, and the static type of OC is C. Now the question is, does E belong to this part of the descendants? It does not, so this will not compile. Okay, E is simply just here. It's outside the descendant classes region. Okay, that's just a quick review of the substitution. Okay, again, if you are curious about what's the rationale behind doing the substitution over here, you can refer to the intuition from a polymorphism that we talked about last time. Review that and make sure you understand that. Okay, now we'll just talk about rule. Okay, so now let me just define very quickly polymorphism and dynamic binding, and then we'll see some example quickly. And then we'll go to another topic, which is related, cast. So what's really polymorphism? This is more like a Latin word. Poly simply means many, and morphism means the shape of the objects. So polymorphism simply means we may have different shapes for particular objects. For example, let's say over here, let's say if I declare a student variable to be of static type students. In that case, how can we substitute for this particular variable? According to the rule, we can substitute this particular variable by any of the descendant classes, like resident students or non-resident students, right? So that means we got different possible dynamic types for this particular variable. So that's about polymorphism. We got multiple different shapes. And now, let me just ask you one thing over here. Okay, let me switch to the iPad over here. Okay, remember we got this type hierarchy over here. We got students over here, and we got resident students. Okay, and then we got the non-resident students over here. Okay, we got three classes over here. Okay, if I have, guys, please, all right? Let's see over here, we have students class, student S over here, and then we have resident students RS, and also we got non-resident students NRS. Okay, what's really polymorphism? Let's talk about polymorphism first. Polymorphism over here, that means an object may have different shapes. What can be shape number one? Let's say we got S is simply assigned to new resident students. In this case, this will compile because RS is simply a descendant class of students, right? That's what we talked about last time. So this will compile. The consequence of that is S is now going to point to a resident students object at the runtime, right? That's one possible shape. And after this line over here, I can do another one to say S is reassigned to a new non-resident students objects over here. I can also do that. So what does that mean? That means I'm going to reassign S to a different object over here. Let me use better color. That means rather than pointing to here, S is now going to point to just another object of different type, NRS. Okay, it's just a different type. So that's polymorphism. You can change from RS into NRS. Both are valid, code to write. Okay, that's about polymorphism. And now one more question for you. How many versions of get tuition do we have for this particular hierarchy, get tuition? We definitely get tuition here for calculating premium rates. We also got another get tuition for calculating the discount rate, right? We got two different versions. So So now there's another concept continue to the polymorphism. Given that student S was declared as student objects, that means we got at least one version of the getTuition that's going to be called, that can be called at the runtime. But which version exactly? So we are really talking about runtime behavior. Okay? So now let me just go to the definition and then we'll go back to this example here. So now, so we got different versions of getTuition that can be called. Let's go to another concept which is related. Dynamic binding. So when we try to call a particular method, so which version exactly will be called at the runtime? It depends on what the dynamic type is for that object at that moment. So what do I mean? So if I go there, let's see this. Let's say immediately after this, I say s dot get tuition over here. And then immediately after this line, I also say s dot get tuition. Okay, we got two lines over here. So now, are they going to call the same version of getTuition though? That's the question, right? After this line, basically we know that S is actually pointing to a resident student's objects, right? That's basically this arrow over here, as we said, over here. And for that particular S object over here, the resident student has got a premium rates of something, right? So that means when we call this particular getTuition, it's going to apply the premium rates. That's one version. Agree? Okay. And then after this line, what do we have? We got another s.getTuition, but what's going to change here? Well, if you think about what has really happened over here, if you think about especially this line over here, the orange line is basically reassigning S to another object at the runtime. That means S, rather than pointing to the resident students, is now going to point to the non-resident students objects, right? So now, when we try to call exactly the same line of code at the runtime, it's not going to have the same effects, simply because this is exactly what dynamic binding means. Dynamically speaking, the dynamic type over here for S is RS. That's the dynamic type. And at this point over here, the dynamic type for S changes to non-resident students, right? It changes. Dynamic type is NRS. Depending on what the dynamic type is, it's going to call different version of the method. In this case, it's going to call this particular version of the getTuition for NRS, in which case you're going to apply the discount rate. Okay, that's about dynamic binding. Okay, any questions? I'm still reviewing what we have said last time. Okay, that's about dynamic binding, so you're okay with that? So that's exactly the same example I talked about. Okay, so now let me just go over one more example series and then we'll go on to the cast, okay? So I got over here. How about we go to the smartphone example over here, okay? So this is the hierarchy that we are talking about. Okay, let's do some practice over here. So that's a hierarchy, okay? It's a different example, so different hierarchy here. More complicated than the student example. Okay? So now let's go line by line. Line number one, over here. When I say smartphone, my phone, so what does that mean? That means I'm declaring a variable called my phone, where smartphone over here is the static type for that particular variable, right? That's what I'm declaring that to be. And then I have two variables over here. I got IP, I got SS. Okay, so you can see that these are their respective static types. Okay, let's do some practice. Okay, now let's say I give you two different lines to judge if they should compile or not. And remember the principle I said: to judge if something should compile or not, you should only look at the static type. Dynamic types in this case is not relevant. Okay, why don't we look at this particular one first? My phone is assigned to IP. Well, this one says it's legal over here already, but do you see why it is legal? Okay, how do we judge that? Okay, I'll just do this one for you. So what you should really look at is the static type for the both sides. So for IP, what's the static type? Well, it's an iOS, right? You can see IP was declared over here with iOS. So the static type is iOS. Okay, that's a static type. And let me just put it inside the diagram. So iOS is the static type of IP. Okay, that's the one. What about the left-hand side for the assignments? For the left-hand side is my phone. What's the static type of my phone? Smartphone, as we declare over here, okay? So I will just highlight that over here. So that is the static type of my phone. And now, if I want to do the following assignment to say my phone is assigned to IP, I should ask the following question. Is the static type for IP, which is iOS, is it a descendant class of the static type for my phone, which is smartphone? It is, okay? Check. Okay, that's the very first basic check you should know how to do, okay? And the rest is similar, okay? I'll let you figure that out, okay? Now, let's talk about dynamic binding very quickly. And somehow related. Let's look at this part of code over here, okay? Again, we declare a variable over here, smartphone, to be my phone, okay? Now, when I talk about dynamic binding, that means things have to be analyzed in a dynamic way, which means you have to keep track of how the dynamic types change for the variables. Let's see. So I already got some diagram over here. So now you can see smartphone was declared to be the static type of my phone, right? So you can see smartphone over here is the static type of my phone. Okay, let's make a note of that. So now let's see line by line if they should compile or not. And then we'll decide what's going to happen at the runtime. So there are two different issues here. Let's have a look at the first line here. When I have this line over here, how should I know if that should compile or not? How do I know? Well, apparently you can see that this class over here is different from this class over here, right? They're different. But now how do I know they should compile or not? You should know about some ancestor-descendant relationship, right? Let's do that very quickly, okay? So iPhone 6s Plus is the new dynamic type we would like to assign to this particular variable. So where is that? Let's just switch to that. iPhone 6s Plus over here is a new dynamic type we'd like to change into. And on the other hand, what's the static type for this particular variable? It's iOS, right? So I go back there. iOS is exactly here. So now I ask the following question. Is this new dynamic type a descendant class of the static type for the variable? It is, okay? That's why it should compile, no problem. And similarly, you can do the similar exercise for this particular one. It's also going to compile. Okay, I'll let you do that exercise. Now, let's try to trace the code very quickly. So now I do have my phone over here, and then I do have iOS, and iOS is IP. It's pointing to an iPhone 6s Plus objects over here, right? That's the dynamic type. So after this line over here, the dynamic type of IP is iPhone 6s Plus after this line, okay? We're just trying to trace. And now, can I do this line over here to say my phone is assigned to IP? Can I do it or not? Would it compile? Okay, what should I look at? Over here. Yeah, we want to see the static type, right? What's the static type for IP? iOS, that's declared over here, right? That's iOS. Static type. What's the static type for my phone? Smartphone. Is iOS a descendant class of smartphone? Is iOS a descendant class of smartphone? Yes, it is. So that one will be okay. Okay? So that line is fine. So what will happen is, so my phone is now going to point to the same object as being pointed to by IP, right? That's what we will do from this line here. And now, after this line here, okay, I'll just put an arrow over here. After this line over here, the dynamic type of my phone is going to point to this particular object over here, right? So that means dynamic type of my phone will be iPhone 6s Plus. 6s Plus. Okay, now let's try the next line. If I try this line over here, surf web. Now let's decide, should it compile for this one here? It should compile, but why would it compile? Again, my phone over here, we know that the static type is smartphone. Let's write it down. Does smartphone declare a method called surfWeb? Does it? Well, let's verify. Smartphone over here, it does declare a method called surfWeb. So that will compile. Now, after we know that it's going to compile, which version of the which version of the surfWeb is it going to call? It depends on the dynamic type, right? So in this case, it's going to be iPhone 6s Plus, right? It's a dynamic type. Okay, that's why I said over here, that's a version of surfWeb using possibly Safari. Okay, now let's do one more. Let's say we got another line over here. We got SS. It's pointing to a galaxy, let's say this particular model here. So that's what SS is pointing to. So now the dynamic type is this particular one. Now let's do another reassignment over here. If I say my phone is reassigned to SS, okay, again, would it compile? The same analysis, right? Look at the static type for both sides and check the descendant. I'll let you do it. So now that means my phone, rather than pointing to here, it is now going to point to this particular objects. That means that one has a different dynamic type, right? So that means after this line here, the dynamic type of my phone is going to change to Galaxy S6 Edge. So now you can highlight that they are different from the two lines, right? They're different. Since they have changed, so now if I try to call this particular line over here to say my phone does surfWeb, which version is it going to call? Well, depending on what the dynamic type is, right? It's going to call exactly this version over here. Okay, that's the one. Did you get a feel just about, when you check for compilation, look at the static type for both sides. And then if you want to see which version of the method is going to be called, you look at the dynamic types. Okay? All right. Now let's go to, so that's about these examples, you can go over them. So now we need to talk about something that's a continuation of this. Okay, so this one we have talked about already. Okay, let's go a little bit further. We want to talk about how you can do casting. But why would you want to do casting? Let's see some motivating scenario. Okay, let's just go over lines of code and then we'll go to iPad. Okay, line number one. So we go back to the only 3-class hierarchy. So we got students on the left-hand side. Also, we got resident students on the right-hand side. Should this line compile in here? It should, right? Because resident students is a descendant class of students. That's no problem. And then, is this line going to compile? This one? If you think no, why not? Okay, the static type for Jim is students, right? Is students a descendant class of resident students? No, so this wouldn't compile, okay? Let's say, that's good, that's all good. And then let's say what we intend to do is to say rs.set premium rate is 1.5, right? So now, here actually poses a potential scenario for us. Let me just switch to iPad and show you. Okay, let's have a look over here. Okay, we still got this 3 lines of code over here. Let's draw some diagram over here quickly for you. What's going to happen when you say line number 1? So Jim is pointing to a resident students object where we got a name to be Jim. And every resident students object should get a premium rates to be set up eventually, right? That's how we know. And then let's say our intention really is eventually we want to set the premium rates for this particular resident students object to be 1.5. That's what we want to do, okay? So we simply say, why don't we simply reassign Jim to be a resident students, and then we can set it. Okay, that's what we want to do. Now, one thing to highlight for you. If you look at this particular line over here, if you look at that, and I would like to just say at this particular point, at this moment, what's the dynamic type of Jim? What is that? Dynamic type. Dynamic type simply means what kind of objects is Jim pointing to? Well, how do you figure? Well, if you see from the first line over here, you can see Jim was created to be a resident student's object over here, right? That means after this point, the dynamic type for Jim is simply just resident students. Okay, so it is resident students. Guys, are we okay for this? Okay. So now, we know that at this point, the dynamic type is really a resident students objects. However, Java compiler would not allow us to do these assignments over here based on the rules that we talked about last time, right? Because we simply know the static type for Jim is not a descending class of resident students. So what do I mean by here? What I meant was, we know pretty well if we try to trace the code. At this point over here, Jim is really pointing to a resident student's object at the runtime. But Java compiler is not very flexible to allow us to change the premium rates to be 1.5. It doesn't allow us to do that. Okay, that's the point. However, this boils down into some problem that's very fundamental. How many of you are taking 2001 at the moment? How many of you? Have you guys talked about undecidability yet? Not yet? You'll get there not in a moment. You'll get this maybe sometime later in the semester. Okay, I want to just mention one thing to you. Okay, let me just write it down exactly what I want to point out here. At this point, Jim's dynamic type is really a resident students, but Java compiler would not allow us to assign Jim to a resident students object over here. It wouldn't allow us. Okay? Since we know it's really pointing to this object at this particular moment, but it wouldn't allow us. So it seems like Java compiler is not very flexible. Okay? I want to just mention this very quickly. Okay? Now, for those of you, just for this keyword over here, undecidable. Undecidable simply means this is a particular problem that simply cannot be solved by computer automatically. Okay? Let me propose the following question to you. Okay? If you can write me a program that would take two inputs. Let's say you take any Java program over here, like a Java file. You take just a variable name. If you can tell me what's really the last dynamic type for X. Let me give you one example. Let's say if I give you this particular file for the Java, okay? I simply say declare student S in the first line. Let's say in the very last line, I simply say S is reassigned to RS. So if I give this particular Java file as a first input, and then I give S to be the second input. So what should be the output over here? Well, the last dynamic type would be resident students, right? So this will be an example run for the program. However, can you actually write a general program for this that will take any Java file with any complicated structure and tell me what the last dynamic type is? It turns out this is impossible. That's why it's called undecidable. If you can write such a program and give it to me, you deserve A+ for this course. And more than that, you should really get a computer science degree right away. Or you should get a Nobel Prize. Seriously, because this is simply not a possible program to write. Okay? So now, what I'm trying to say is over here, in general, let me give you just one counter example. What if the program looks like this? I simply say while true. And then I say students S. I say over here, S is assigned to new resident students over here. Given this fragment of code, what's the last dynamic type for S? What's the last one? Can it be resident students? What the last one, if you try to execute this code? In fact, what does this mean? It simply means the loop will never terminate, right? So that means if, in general, you just cannot analyze any arbitrary structure for the code, because the code can be arbitrarily complicated, the best way you can do is to simulate how the code runs. What if the code doesn't terminate? That means whatever program you write will also not terminate. Okay? So I'm just trying to say this problem here in general is not decidable, it's not going to be possible. So that means the Java compiler that you're using for the Eclipse, you can also not decide what the dynamic type is for your program, for any particular variable. Okay? That's just an aside. Now let's go back to the previous one. Let's go back to this particular fragment of code here. Okay? So now, at this point over here, even though we know that the dynamic type for Jim is really resident students, but the Java compiler has no knowledge about it. All the Java compiler knows about is they can only check for the static type for Jim. That's all they can do. Okay? They check that this static type for Jim is simply students, and student is not a dynamic, it's not a descending class of resident students. So they would say, no, it wouldn't compile. But what if you're really sure as a programmer? Okay? So here comes the motivation for cast. There's something we can do. Okay? Let's see from the slides. Again, we're given this fragment of code. How can I really make this particular code to compile? It's possible. If I'm so sure Jim is really pointing to some resident students objects I'm thinking about at the runtime, I can definitely do that. The way to do that is by doing a typecast. But how do we write a syntax for that? Okay? Let's see over here. The syntax for that is something like this. I want you to compare line number 2 over here to say resident students RS is assigned to Jim. That one there, we know that it wouldn't compile, right? On the other hand, if we look at this line of code over here, it will compile. Okay, that's the difference. But how do we know how to write the syntax? Let me just analyze the syntax for you over here. Okay, let's put it here. If I got students S is assigned to new something here, let's say this, resident students, like that. And then if I simply say resident students RS is assigned to S, we know that it wouldn't compile. That's what we know very well, okay, by applying the rule for substitution. What we can write instead is something like this. We can say RS over here is assigned to, let's now do a cast and put S over here. And the cast is basically like how you would cast an integer, how you would cast a double into integer, the same syntax. But now the concept is different, okay? So now what I can put is, if I'm so sure S is really pointing to some dynamic type of resident students, I can just put RS over here. Let's learn about the syntax first, okay? The syntax is going to be, you have an opening parenthesis, you also got closing parenthesis, and you put a type over here. There will be a certain rule you have to follow. I will explain the rule to you, okay, in just a moment. So now this can be just a class name over here, okay? So now what does that mean? Let's first understand what that really means. That means we are going to only temporarily change the static type for S. Only temporarily, not permanently, only temporarily. Okay? So what they will do is like this. Like over here. So we simply temporarily change the static type to, used to be, here we know that just S alone over here, the static type is students. Now after doing such cast, temporarily we change the static type to be RS, to RS. So now, after this cast, let's apply again our rule of substitution. Is now RS a descendant class of RS over here? It is, because it's simply a descendant of itself. So this will compile. Okay? That's basically how a cast works. But we should get more intuition about how it works. Okay. Let me just mention more about this. Okay, you can definitely go over that. So now what I would do is this just another similar example. But I'll go to something about a little bit about syntax. There are two different ways you can do cast syntactically. Okay, either you can try to do the cast and then give it a name, or you can just try to do the cast anonymously, like how we create new objects. Let's see how we can do that. Okay, let's say over here. Okay, just go to the line. Okay, so you can either do a name cast over here, you can do anonymous, or you can do something that's problematic. Okay, let's see how each one of them will actually work. The first one over here, can we just start with the first one over here? This should compile, agree? Because we got the type over here, iPhone 6s Plus. As we can see from the hierarchy over here, iPhone 6s Plus is here in the class in the hierarchy over here. Is it a descending class of smartphone? Indeed, it is the root of the hierarchy. So this line should be okay. And then we are trying to basically say a phone is we are trying to cast that into iPhone 6s Plus. Let's just say it is allowed. Okay, I will talk about the rule in just the next slide. I'll just talk about syntax first. So what this will do is this particular cast is going to temporarily change the static type for a phone. That's what we will do. A phone at the moment is of type smartphone, which cannot be directly assigned to iOS variable. It's not possible. However, if we can do some kind of cast, we can temporarily change the static type. In that case, we can do the assignments. So how does that work? So that means over here, we temporarily change the static type of a phone to iPhone 6s Plus. That's what we're trying to do. So now, given this new temporary static type over here, does the rule of substitution is satisfied? Are they satisfied? Is this particular new static type, even though it's temporary, is that a descending class of iOS? It is. If you look at that, iPhone 6s Plus is over here. It's a static descending class of iOS. So it's not a problem. Okay, that's how we do cast. Okay, so now one more thing to show you. Okay, we want to look at another syntax over here, this one here, anonymous cast. Okay, so now this is where we do a cast and reassign that to another variable. That's what we did. Okay, that's a name cast. What about anonymous cast? The idea is very simple, like this. Basically, we're trying to do the following over here. We try to say a phone over here, we cast that into iPhone 6s Plus. We do that. And then we don't really have any intermediate variable like over here. We don't. We simply just try to use that and then apply it to some method. Okay, that's what we can have. But we explain how this method can, what method will actually work in this particular context. We'll talk about it. Okay. Now, I'll go over this problem maybe a little bit later. Let's just go to some idea about how we can do cast. Okay. The best way to understand what how a cast will work is to think about expectation. Okay. Let's now see the following. Okay. Let's see this example here to get some intuition. Okay. What you have is, let's say I got my phone over here. Okay, a variable. And the static type for my phone is simply just Android. Okay, what I will do is I'll highlight it in green. Android. So I'll put Android over here, Android. So this is the, put in green maybe. So this is the static type of my phone. Question for you. If I declare my phone to be of this particular static type, what methods can I call on my phone? What will be the expectation? How many methods can I expect to call for my phone? How many? According to the hierarchy here. Well, you should look at the method that's declared at the current level, surf web, Skype. and also dial and surf web over here, right? So in total, you got either dial, surf web, or you got Skype, right? So these are the three methods you can call, okay? So now, let's try to go a little bit further, okay? So the static type over here tells you about the expectation, okay? And remember, we said something like, if you're trying to go down the hierarchy over here, would you get more expectation to the descending classes or you get less? You get more. For example, if I go to, let's say, this one here, Galaxy S6 Edge Plus, do we get more expectation here than Android will get less? You definitely get more, right? For example, site sync is an extra method that we can expect from this particular type, okay? So the lower you are in the hierarchy, the more expected methods you can call on this particular variable. Okay, let's keep that in mind. On the other hand, what if we go up the hierarchy here? We tend to get the opposite effects, right? If you try to go up, that means you get less methods to be called. In this case, you cannot, if I go up over here, go to smartphone. In this case, what I will get is I can only call dial and surf web, but not Skype anymore. So I get less expectation. Okay? So now, what that means is, let me write it down and then we'll talk about it. Okay? For the expectation here, if I talk about my phone over here, for my phone, I can simply call Skype, and I can call surf web, and I can also call dial. So these are the three methods I can call. Okay? Let's just see another one. What about if I have SP over here? SP is of type smartphone, right? If I say SP over here, smartphone, I can only call less. So that means I can do style and surf web. Okay, not a problem. Let's do one more. Okay, so this GA over here, Galaxy. So that's lower in the hierarchy, right? That's exactly over here. That means I can call not only these over here, I can call something extra, right? So let's write it down. So what I have over here is I got dial, I got surf web, I got Skype, and I also got site sync. Okay, so these are the four methods I can call, right? So the lower I am, the more expectation I can have. The upper I am, the less expectation I have for the type. Okay, how does cast have to do with this? That's the question, okay? Since the cast allow us to actually temporarily change the static type, that means the cast will allow us to also temporarily change the expectation for the variables. That's what that means, okay? Let's try this. If I try, what I will do is I will highlight the direction for you over here. So this Android over here is the static type for my phone, okay? There are two kinds of cast you can do, two kinds. Either you can do so-called upward casting, okay? I'll write it down here. You can do upward casting, or you can do downward casting. Okay, either direction. Okay, let's see what they really mean. Let's do the simpler one. Okay, if I do an upward casting over here, that means I'm basically casting the variable to any of its ancestor classes. That will be allowed. Okay. What about downward casting over here? For downward casting, that means I'm trying to cast the methods, the objects, into any of its descendant classes over here. That's what I'm doing here. So you can see the pink and see the orange over here. So what's the effects we have over here? Okay, let's see. If you try to see this particular one, let me see if I got anything here. Okay. Let me use a different page. Okay. So now, do I have the diagram over here? Let me just find it, and then we'll talk about it. Okay, let's use this a new example over here. Okay, let's try the following. What I want you to look at, let's look at the syntax over here, the anonymous cast. Okay, let's look at that quickly. Let's say here, again, I have smartphone over here, and my phone is assigned to something over here. Okay, that's how we start with. And that is a static type for my phone. Okay, you know what? I think a better example could be, I use maybe Android. That'll be a better one. Okay, let's look at this, Android. And then I'm going to highlight over here. I can now do two kinds of cast over here, either upward or downwards. Let's try the upward first. If I try the upward casting in the following way, what's going to happen? I'll say upward casting. Okay. I would say my phone, and then I can cast that into any of the ancestor classes of the static type, in this case, smartphone. And then I will simply say smartphone over here. Okay? And if I put a parenthesis over here, it's going to be a new object expression. Okay? And now, what I have over here is this object expression has got a different static type, which is whatever I try to cast that into, which is smartphone. Agree? That's what we cast that into. So now, what would be the expectation for this particular expression? It would be only up to what its new static type is, which is smartphone. So what can we call on this particular expression? Dial and surf web. Agree? So I can say dial, and I can also say surf web. But to really give you the comparison, if I only have my phone alone, I'll put my phone over here. Remember, for my phone, the static type is actually Android. So I could actually call dial, I could call surf web, I could also call Skype, right? If you now compare these two expectation, right? This is the expectation after I do some upward casting to upper in the hierarchy. And this is before the cast. It seems like I get more expectation, right? So that's what you can do for the cast, to do upward casting. Because now you can see that I used to be able to call the Skype over here, but now I cannot do that anymore. So it's not one of the possible expectation anymore. So I cannot do it. Yes, go ahead.
What is the point of upward casting? Because you already have more methods. You can choose whatever.
Yeah, so the question was, what would be the benefits for upward casting? I would say typically you want to do downward casting, but for upward casting, it's more like an access control. So that means I'm trying to restricting what methods you can call for any other potential caller. So now maybe I simply don't want to make this particular feature available, so I just cast that into to the upper level over there. So that's what I would do. Okay? Let's now do the other direction. Okay? Let's just try to see if that will help. Let's do another one, which is downward casting. Okay? What happened to the downward casting over here? So you kind of see it's the opposite effects of the upward casting. For upward casting, we are creating some objects over here which got less expectation, less methods to be called. What about for downward casting? We're basically creating something that for which you can call more methods. Let's see one example here. Okay? What I will do is, let's see over here, I can say, let me use red. If I say my phone over here, okay, my phone, and then let me cast that into, let's say, this particular class. Okay? This is a downward casting because I'm simply casting from Android into one of its descendant classes. It is allowed. Okay? So now if I say that, let me give you myself a little bit more space. So what I would do is I'll say my phone over here, and then I'll try to cast that into this particular class. So Galaxy S6 Edge Plus. That's what I would do. So after this cast, I'm creating a particular variable object expression over here. And what's the new static type? Well, whatever I cast it into, right? So now the static type for this particular expression is Galaxy S6 Edge Plus. So now for this particular object expression, what can I call on that? What's the additional method I can call on this particular one? Sysync, agree? Because now you can see not only that, so basically now this new static type is over here. Not only that I can call dial, surf web, and Skype, but also I can call Sysync, right? So these are the 4 methods I can call, okay? So I can call basically dial, surf web, and then Skype, and also site sync. Okay, so these are the 4 methods I can call. Guys, are we okay so far? It's a hard subject, as I said before, so try to follow as much as possible. Okay, I'll give you some practice problem over the weekend, so hopefully that will help. Okay, now that's about this particular. Any questions before I move on? Okay, well, maybe we should see more examples. Okay, that's about this one here. Okay, this is what we just talked about over here. So now, when you go over this slide over here, that's exactly what I just tried to demonstrate. Whenever you want to, let me just summarize what we have over here. Okay. Whenever you have any particular, let me abstractly speaking. Let me just summarize over here. Over here, you have the Android being the static type over here, right? My phone. The static type is simply Android. So that means this is our starting points. So now this is the rule. If you want to cast this particular variable into some other type, so what can you put over there? Okay, let me just start again. Okay, let me just put the diagram back again, and then I'll summarize. Okay, again, the same diagram over here. Okay, so now here's the following, here's what we have seen. Yeah, go ahead.
Can you just explain what you mean by having the Android as a static type?
Sure. Let me just start with that and then I'll explain. When we declare a variable, let's say P over here, to be a static type Android. Again, we talk about expectation when we talk about static type, right? So we know that Android over here is the static type for P. And having a static type simply means we know what method we can call on this particular reference variable, right? So we know that because the static type is simply Android, we can call any methods that's defined at this level over here, and also all the methods that's inherited from the ancestor, right, as we said last time. So in this case, we can definitely call p.Skype. So this is a new method from here. And also we can call p.surfweb. Also we can call p.dial. So these are all the methods we can call on this particular variable. That's what the static type really means. It tells you what methods you can call.
So we don't declare something as static type as long as we know what the methods are?
No, actually, so it's the opposite. Whenever you want to declare a variable, you have to give a type, agree? So now in this case, you got many options over here. You can either declare P to be of smartphone, you can declare that to be iOS, or can be Android. You got many options over here. But as soon as you commit to your choice over here, let's say Android, that means you're pretty sure at the runtime, you only want to call all the methods that's declared at the Android level or all the level above in the ancestor. That's kind of the decision you have to make, okay? But sometimes you might find that you want to change the static type temporarily. That's why we got a cast for you, okay? So now let's just do one more time, okay? So now here's the following question. What kind of cast will compile. What kind of cast will compile? Okay. If we talk about what kind of cast will compile, when we do cast over here, this is a principle you have to know. The cast simply temporarily changes the static type. That's what it does, okay, as I said. Now, from here, how can we change the expectation for the static type? You can either make it less or you can make it more. How do you make it less? You go to the ancestor classes. How can you make it more? You go to the descendant classes. That means when we talk about what kind of cast will be compilable, this is visually what you should know. What kind of cast will be compilable? Given this particular static type for the variable, you can either go upwards or downwards. Now, let's summarize visually. That means you can either go upwards, which is over here. That will be the upward casting. In which case, you're trying to narrowing your expectation, make the expectation less. Narrow expectation. On the other hand, you can also try to do downward casting in this way to any of the descending classes for the static type. So this will be downward casting. In which case, you're trying to widen to make the expectation more. Widen the expectation. Okay, that's what we are doing here. Okay, so these are the two possibilities that will actually make it compile. Okay. Yes? Huh? Or more precisely, it temporarily changes the static type and then creates some new kind of like an expression for you to call the method. Let me show you over here. You can see over here, let's say for this particular line, if you look at that over here, right? So we used to get my phone over here, and then we cast that into a smartphone. So we only temporarily change the static type of my phone, and then we are creating a new object expression over here. So this is not exactly like the original my phone. It's a new expression there, and then it has a new static type called my phone.
So then in the next line, we're going back into whatever.
Yeah, since in the next line, since this expression here is not anonymous, so you don't actually capture that. Okay. So how do we make a difference over here? So what I can do is, I can go back here and say the following. If I say over here, P over here is of type Android. Okay? If I say P is assigned to, okay, let me just make it a little bit more complete. So Android P is assigned to, let's say, again, let me just make sure this one is properly illustrated. Again, I will bring the image back. Okay, I'll put it here. Let's say over here, let's use the same example. Android, and then P is assigned to new. Now let's say use this as a dynamic type. Galaxy S6 Edge Plus, okay, some parameter over here, okay? What that means is, if I got P here, it's now pointing to some objects over here. Galaxy S6 Edge Plus, okay, so far so good? So now, what I can do is by using a cast, because I know that at the moment I can simply just do P dot Skype. I can also do P dot surf web. I can also do P dot dial. So far so good, right? Can I do at the moment to say P dot site sync? Can I or can I not? That's a fundamental question. Can I do it? You would think you can. You would think. Since we are pointing to a Galaxy S6 Edge Plus object, which does define the site sync objects, right, at the runtime. So you would think this is okay. It turns out, no, it's not okay. Because whatever method you can call on this particular variable depends on the expectation for that particular variable. And the expectation comes from the static type. In this case, the expectation comes from the static type for P, which is Android. And Android at this point does not declare site sync, so you cannot do it. Okay? A little bit better, right? So guys, just keep asking me questions. Otherwise, I will assume you're okay, please. Okay? Yeah, let me continue with that and then I'll answer your question. So now let's go a little bit further. How can you make the compiler happy? All the compiler can do is to look at the static type for your variable over here and then try to see if that particular static type defines this method you're talking about. It does not, so it doesn't compile. Okay? It's easy as that. Okay? Now, for you as a programmer, you're so sure after this line over here, P is really pointing to this object here. How can you do? Cast. What you can do is, since I'm so sure it's going to, compiler is going to be not happy, how can I make it happy? Let me do a cast. A cast is basically to tell the compiler, do whatever I say, right? Don't worry about your rule before, okay? So now let me write it down and then we'll have more discussion. So what I can do instead is to have something like, to say, let me just put it down over here. I can say Galaxy S6 H plus, and then I would say P2, okay, just a new variable. And then I would say this is assigned to something over here, okay? And this something over here is going to look like a cast notation, okay? I will do a particular cast over here, and then I'm talking about the same objects P. I'm not really creating a new object. Don't misunderstand. I don't really create any copy of the objects, the same objects, okay? So now I got P over here. P is still pointing to this particular objects, but now I'm just creating a new reference to the objects, okay? So what I'm doing over here is I'll temporarily change the static type Galaxy S6 H plus. So now what does that do? What that does is it creates a new alias reference over here called P2, and P2 is pointing to the same objects. However, there's a crucial difference at this point. Okay, I'll write it down. The crucial difference is the static type for P over here is simply just Android. And that's exactly why we cannot do this particular p.sitesync. That's exactly why. But now, after the cast over here, we are basically doing a downward casting. We are casting this particular P2 into one of its descendant classes. And then we try to do some reassignments for the references, right? So now P2 over here is now getting a different static type, even though they're pointing to the same objects, okay? So now the P2 has a static type, Galaxy S6 H plus. So after this line, what does that mean? That means we got two variables here. We got P2 and we got P. They both point to the same objects. However, from the compiler's point of view, these two variables got different static types. One has Android, as we originally declared. And the other one has Galaxy S6 H plus, which we just did by using a cast. So now you can actually do P2 dot site sync if you wish. After this, we can say P2 dot site sync. And would this compile? It would, because now P2 has a different static type, so you will compile. Makes more sense, maybe? Did you have a question, or you're okay?
First line was compiling, right?
The first line, which one?
Android P new, yeah.
You mean, you talking about over here?
The
What?
very first line, Android P.
Yeah, this will compile, no problem.
So what, if you cannot extend the expectation, what is it doing?
So basically, over here, this line here is telling us we're declaring a variable called P. All we can expect on P depends on what the static type is, which is Android. That is why we cannot do anything like this. P.sitesync would not be okay, because sitesync is outside the expectation for Android.
How would be assigning for the new Galaxy?
That one just to say which object it is pointing to. That's more about dynamic type, right? So yeah, before I take a question, yes, yeah. Anything to follow? Yeah, go ahead.
You lost
Yes. Remember I said, okay, normally the compiler would simply look up the static type as is from the declaration, right? That's why the compiler would think for P, the static type is simply just Android. We're okay with that, right? That's how we declare that to be. Now, the casting basically is to add more flexibility for you as a programmer. If you don't want any flexibility like this, you simply cannot do p.sitesync, right? That's what we said. You cannot do it, even though you're pretty sure it is really pointing to such objects that should support sitesync. Yeah, because all the compiler can tell is a static type. They can only see if the static type of this particular variable has a sitesync. In this case, Android does not have sitesync. That's why this line would not compile. Now, let's go a little bit further. For you as a programmer, if you're so sure it's really pointing to such object that will support the sitesync, you can tell the compiler, now, create a new reference for the same objects for me. But now I'm going to have a different static type for that. I'm so sure it is the case. But there's a danger to this, which we'll talk about. There's a danger to this. Okay? So now, since I'm so sure that this P is really pointing to a sitesync, to a Samsung, this particular class that will support a sitesync. So what I can do is I can just ask the compiler, so now do a cast for me like this, cast P, doing a downward casting to give more expectation. So what that would do is it's going to say whatever type you want to cast P into is going to be the new static type over here for this new variable P2. That's what they would do. Better? Or which part? The very last part. The very last part. Okay. The very last part basically is to say, okay, can you see that we are creating a new variable P2 over here? Okay. Now for P2 over here, P2 somehow comes from P. Agree? And there's no new keyword over here. So that means we are not creating any new objects. It's pretty much like a P2 is assigned to P, like how we discussed before. P2 will just point to wherever P is pointing to. The only extra complication we have is this cast expression over here, just with the parentheses over here. Agree? So now how do we deal with that? That one there simply tells you P2 is going to point to the same objects, true, but something extra to that. What it will do is it's also going to make sure P2 is pointing to this, but the expectation for P2 will be different from P. That's what the cast will do. It will change the expectation. In this case, P2, the expectation will be, since we're doing a downward casting into a descending class over here, so it is going to have more over here. So that's why P2 and P, they're pointing to the same objects, but now for P2, you can call more methods because it's a descending class static type. A little bit better, maybe? Okay. Yeah, so if you keep using P only, then P itself always have the Android static type. So that one never changes. Yeah, exactly. So now if you say P only, you can only have the expectation that does not include the sitesync. It does not include. But now I want to include it because it simply is pointing to this particular object over here. So what I can do is I can do a cast over here. That's what I can do. That line will compile. Yeah, okay, yeah, okay. So now let's go a little bit further, okay? I'll try to maybe recap this maybe next time, but let's do one step further. So we talk about there are two kinds of casts you can do. Either you can cast upwards over here to get less expectation, right? Or you can go to cast downwards to get more expectation. Okay, that's about whether a line will compile or not, right? Just by looking at the either it's upward or downwards. Okay, but now there's more issue to it. Okay, let's see the following code. Okay, let's have a look at this. Okay, let's try to apply our knowledge about downward casting or upward casting. Okay, let's try. So what I have now is, let's go line by line. Line number 1, so Jim has the static type students. Okay, let me put it here. Again, let's go back to the simpler example first to begin with. So Jim is of static type students. Jim is now pointing to a non-resident students object, right? over here. So we have a non-resident students object over here, and which should have a discount rate attributes. Okay, so that's all good. And we know that this line here should be okay because non-resident students is a descending class of students. So we know that that should be okay. What about line number 2? Line number 2. Are we doing a downward casting or upward casting? At least you can tell, right? Well, we know that, first of all, what's the static type? The static type for Jim is simply students, right? It's over here. And now we are trying to cast that into a resident students, which is over here. So this is a downward casting. Okay, over here. So this is a downward casting. Okay, it's a downward casting, so that will be okay. But can you see anything wrong with this? Okay, I will say that very briefly over here, and then we should try. So now what's really wrong is, let's apply what we have learned. So this is downward casting, that means this will compile, no problem. However, you can see that after this, what's going to happen is, since we are trying to cast this Jim, which is of static type students, into a resident students, that's no problem. However, what Jim is really pointing to actually is a non-resident students objects. Agree? So now, again, everything is about expectation, everything, okay? This will compile. So now, after this line number 2, what's going to happen after this line? After this line, what we have is, we got RS over here, is pointing to the same objects. And what's the static type for RS? As we can see, it's cast into resident students, right? So that would be resident students. Do you see any problem over here at the runtime? Well, because we know that for RS, one of the expectation is we can say RS dot premium rates over here. Does this particular object have premium rates? No, it doesn't. But it was compilable cast. So what does that mean? That means when we talk about whether a cast should compile or not, we only talk about whether you're casting upwards or downwards. That's it. That's about compilation. But now we are talking more about runtime behavior, right? If you're trying to cast your objects into something that is not so consistent with your dynamic type, you're going to have some runtime issue. Okay? So, to put it very quickly, when you try to execute this particular line over here, it will compile, no problem. But when you try to execute it, what you will have is something called ClassCastException. ClassCastException. Okay? That's what we have. So why would that be the case? Again, let me recap, and then I will just mention about how you should really study this over the weekend. Okay, what we have is as follows. There are two issues over here. We talk about whether a particular cast is compilable, which means would it compile even? Would there be any red underline? To decide if a cast should compile or not, easy. Either you cast upwards or downwards to ancestor class or descendant classes, in which case you only try to change the expectation. But now, even if a cast can actually compile, when you try to execute a cast, you might run into the so-called ClassCastException. So that's something we have to deal with. Okay? What I will say is, it's a difficult topic. What I will do, I'll spend it maybe at the next half time of the Monday's class to really go over the issue again. I believe your lab test 3 is also coming up, right? Okay? I'll put up some study guide for you for lab test 3. But part of the written question will be about something like this. I'll give you some practice problem for this, and then we'll start again next Monday. Okay?